Okay, so we found out on this last one that as x approaches -2, and yes, the number has to be the same from both the left and right. So as I swoop in towards -2, x, a value of -2 from the left, I notice that the y value is getting closer and closer to +2. But as I swoop in from the right, I notice that the y value is getting closer and closer to 0. So that's why this one does not exist, because the value from the left is getting closer to +2, and the value from the right is getting closer to 0. However, when I look at what happens as we approach 4, so I find 1, 2, 3, 4 on the x-axis, and as I approach 4 from the left, I go, oh, I'm getting closer and closer to 0, and as I approach 4 from the right side, I get closer and closer to 0. So, since they're both the same, left and right, then the limit as x approaches 4 is 0. If I look at what happens as x approaches +2, so here on the graph from the left, I'm getting closer and closer to this value, which is -2. So from the left, it's getting closer and closer to -2. And then I swoop in from the right, and as I get closer and come in closer and closer on the right-hand side of it, it's getting at this value. And so even though it's not defined there, I am getting closer and closer to -2. So the limit, the y value is approaching -2 from both the left and right sides of x equals 2. Excuse me, so the limit is -2. When I look at the graph and I'm just evaluating f of -2, I say, okay, what's the y value when x is -2? And of course, it looks like there's two, one here and the one up here, but the only one that's actually defined is the closed circle. So f of -2 is 0. So some things to look for, some little tricks when you are trying to decide whether or not limits exist. Number one is called a jump discontinuity. And if you remember the day that you had to draw graphs, the second day of school, you actually had some jump discontinuities. You just probably didn't know it yet. Essentially, that simply means that at an x value, we have to pick up our pencil and jump from one point to another. So, for example, I have a piece function every time I have an absolute value. So I'm going to redefine this as, remember, that absolute value is positive if the inside stuff is positive, and so the shortcut is saying greater than 0, which means really this equals, it would equal 1. And the inside stuff will be negative, so I'd have a negative of the inside stuff if x is less than 0. Remember, I'd take the opposite. So x would already be negative, and then I'd take the opposite of it. That's why I write -x. And then that reduces to -1. So if I were to graph this, it would look like, so from the top, it will look like this, where x is +1. And from the bottom, it'll look like this, where x is -1. Now, I suppose technically I could put in even an equal to on either one of these points, dependent upon which one I decide to choose, and then one of those bubbles would be filled in. But here's what happens. If I look at the limit as x approaches 0, so I would swoop in from the left towards x equals 0, and that would be a -1 value, and I'd swoop in from the right, and that would be a +1 value. So they're not equal, so the limit does not exist. I will see you in the next video.